Good morning, everybody. Thanks for joining us this morning. First of all, I would like to introduce Florent Zara, who joined us to work on several topics, including AICE.
Hello.
And then let's go to the agenda for today. So, well, I know that some of you have hard stop at 9:30, so we put the AICE working group topic first because I think that's interesting to discuss about it. And then starting at 9:20, 9:25, we will have a presentation by Boris Baldassari from the Eclipse Foundation and who will be with us? So that's Jean-Pierre et Clément?
Jean-Pierre and Etienne, probably.
Jean-Pierre and Etienne from Aura Healthcare. We will say a few words about what we have been doing together in the context of the Aura Healthcare testbed that was developed in the second part of last year. Next. So just, and I'm happy that I extended the invitation to a few new people. So thanks for joining. But I think that it makes it important to remind, to have a short introduction about what we intend to do in the AICE working group and the AICE Open Lab. So the point is that, as you know, we at the Eclipse Foundation, we moved to Europe. That's part of history now because we have been established in Europe since the beginning of 2021. And as we move to Europe, we focus on a few strategic projects. What's happening? We focused on a few strategic projects that are, from our perspective, very important to Europe. So that includes cloud and edge. And we know that there is a huge investment in research in the cloud to edge continuum, and also artificial intelligence. And at the crossroads of those different topics, we create the AICE working group. So AICE stands for AI, Cloud, and Edge Working Group, and that's a new working group at the Eclipse Foundation that is under creation, and where the goal is to create the collaboration ecosystem in open source on AI, but with also the projection to run AI testbeds and tools on different cloud and edge infrastructure. So the different requirements we address in this working group are really collaboration on testbeds and tools. Also topics like trustable, explainable AI. And we think that open source is necessary to be able to trust AI. But we also think that it enables interoperability. And for the other topics, there is frugality and embedded. That's really how to have AI that is that works with edge computing. Also, one of the goals is really to create this AI open source ecosystem with, I would say, to some extent, from a European open source point of view. So, from my perspective, when I say European open source point of view, that open source is global, and that's our positioning at the Eclipse Foundation. We want to help the European open source ecosystem to thrive globally with and to show global leadership. Next. And so the mission of the AICE working group is to promote the advancement, development, and experimentation of open source software for AI, cloud, and edge technologies. We think that, we think that open source is really the best way to foster vendor-neutral collaboration. And we feel that there is this need to create and publish some reference architectures, some blueprints, and also another aspect, and that's related to interoperability and predictability on the previous slide, is to create distributions of different AI components with what we have been calling for decades at the Eclipse Foundation, release train. So synchronizing distributions of different components to be able to package everything in versions that work well together and deliver that on a specific day with proper communication, etc. Yeah, provide building test suite. So we would be happy to host one of the new upcoming AI platforms like TensorFlow, PyTorch, Mindspore, etc. But even beyond that, we think that there is really an opportunity to collaborate on test suites, on test beds, and also to have some calibrated demo data sets. And that's exactly what will be presented in a few minutes from the perspective of the Aura testbed. And another aspect is that we have a working group, but in this working group, we also want to create an open lab. And the open lab is something a bit new for the Eclipse Foundation, because so far we provide collaboration tools like GitLab, and we provide an infrastructure for CI/CD. But here with the open lab, the goal is also to provide an infrastructure for experimentation, for benchmarking, and with the target that we want with the idea that we want to target different runtimes with cloud and edge runtime, and for example, having the capability to train an AI in the cloud, but to also test how it works in an edge deployment. And of course, because it's AI, we need to take care not only about privacy and security, but also about ethics, and frugality with the edge computing aspect is also a very important one. Next. So some news about that. We are in this phase where we have our working group is in what we call the proposal phase. So at the Eclipse Foundation, we have over the years created something like 20 working groups. And what is, maybe in 2 words, what is an Eclipse working group? That's like a foundation in a box that benefits from all the infrastructure and all the services from the Eclipse Foundation, but gives also the freedom of action to a group of organizations who want to coordinate some open source projects in a specific domain. And so in 2021, we started to work with several actors. We started to work on the draft charter, and we had an initiation agreement with Huawei. So we have Brian Che today, and Jason Shi are here, and thanks for your support on that. And after this phase, we have defined a charter for how the working group should work. We also have some pitch decks to explain what we want to do in the working group. And we have been for the last few months, we have been onboarding initial members. So that includes Fraunhofer, for example. That includes Newsware and more. And we are still in this phase where we onboard more members, because we think that we still need a more critical mass in this initiative. But well, we have good news. For example, we got we are still working on the paperwork, but we had the news recently that CEA is joining as this working group at a strategic level and wants to bring several projects. So that will be the conclusion of the talk. That's the next meeting in a month from now will be a presentation from CEA. And also at the same time, we are onboarding important technologies. So Eclipse Graphene, for example, is the new name under the Eclipse Foundation of AI for EU experiments. So Martin Wels from Fraunhofer is here and is leading the project. And we are onboarding the project, which is a key component in the Martin, which is a key component in this initiative. So if you want to know more information about our process, everything is very well described. We are really at the limit between those two elements. So we have what we call a proposed working group. So you can find the information to join the working group on our website. And we are planning for the launching phase in the coming weeks. Next. So one important aspect is that some of you received a personal invite from me or from Florence for this meeting, but we come to a point where we should use mainly the AICE working group mailing list to send the invite. So if you can, we already have 50 people registered to the mailing list, but if you can join the mailing list, that will make the communication much easier. And so that's both easy and I would like it to be easier, but you just need an eclipse.org account. So that's free and you need 2 minutes to create an eclipse.org. And you are not tracked when you have an eclipse.org account because we have, I think, 80,000 accounts. And then you have the instructions to just go to this page, and you just have to click subscribe to AICE working group mailing list, and you're done. Should take no more than 3 minutes. Next. And then there's okay, we need you to help us grow the ecosystem. And I think that it's both a request for your help, but I think that's also a big opportunity for all of us. When I say grow the ecosystem, that's really about having new projects, new use cases. So that can be platform projects. I was mentioning the big platforms we all know. Like I didn't mention scikit-learn, but that's another interesting one. That can be vertical application frameworks. That can be also use cases, test beds, demonstrators, and also I mentioned that specifically because I know some of you are should typically be interested in that. Is that we have potentially a very good place in this working group to promote research projects from AI research like ICT 48, ICT 49, etc. And I think that if in your research project you mentioned that you want to do open source and to use open source for dissemination and exploitation, that's one of the things that we want to do, and we want to help you do that. And for research centers or universities or even organizations involved in research in general, that's easy to join the Eclipse Foundation and to participate in this working group. So I think, and maybe I want to be proven wrong, but I think that lots of things in Europe in the domain of AI still happen in the domain of research and innovation. And we want to help this research ecosystem collaborate better together and do better open source with a good open source governance. You can also sponsor computing power for the Open Lab. So for the moment, we have computing power provided by one of the partners, which is SDIA. And we need more. If you have a lab with available computing power, or if you have a lab with edge computing capabilities, then we are interested in this. We don't require any SLA because that's really about running experiments, and we are happy with best effort. But the more computing capabilities we have, the better it is. And finally, you hear what we present, and I think that to some extent you are our best ambassadors. So happy to Florent and I are happy to have follow-up conversations with you about how to put everything I just described in practice, and to provide you with some presentation material and to onboard you in the initiative. But beyond that, do not hesitate to point us to potential partners or potential projects that we don't necessarily know for the moment. And you may have the impression that the charter, the goal of the working group, etc., is already fully defined, etc. But like everything we do at the Eclipse Foundation, we do that for the members. So it's still early enough that concretely joining the initiative is the best way to drive the working group in a direction that fits your requirements. And I think that's, Florent, your part.
Yes, a few words about the website. The website, as you know it today, so that's the website is AICE.eclipse.org. Let me put you the website on the screen.
I will add the URLs in the chat.
So only this is the very first version, the basic template, just to have an online presence with join the mailing list right now. So you need an account, don't hesitate to do it. And we are working with, so right now what you can find on this is the mailing list, and also the Aura paper, the Aura demonstrator, the paper that we will present you in a minute. And we are working with Boris on a brand new version with, with more details, details about the working group, what it is about, with direct access to the charter and the participation agreements. Right now, you have to contact us. More news and events, the list of participants and members, some more resources, we'll see in a minute, and a new version of our article. We rework a little bit the article, and it will be online with the new website. And everything is done in the open, so you have the link. You have the link on the GitLab. It's built using Hugo, but if you want to see our progress, you can join us. We're happy to have you. And so here is the first preview of the website. So that's not we will push it to production in a few days, but right now, so that's only not the not the design. The design is not there. That's only what you will find on the website. The design will come later in a few weeks. We are working with the design and marketing team at Eclipse, but right now we are working on what we will put in it. On the front page, you will find a little definition of AICE, how to join us to participate, and the monthly meeting. The list of supporters is we are currently working on, some testimonial. You will also find the news and the event dedicated page, and more resources, like the presentation we've done. You will find the meetup, which was the physical meetup, which was held in Brussels last November, with every slide and video published, and also more use cases with the AICE Open Lab, the healthcare, Aura Healthcare use case, Eclipse Graphene, and of course the new version of the article, which is nearly finished of the article. So this is a work in progress, and you can also give us a feedback directly on our GitLab. Using issues, and you can see you have also done. You will be able there to find the preview of the website. So do not hesitate to come and give us some remarks on it. That's it for the website, Boris. Let's go to the heart of the presentation. That's 9:25. It's okay. We are on time.
Yes, sure. Well, wait, I'll set up the slides again from Aura. Give me 1 minute. Okay. Oh, you have them. Okay.
Yes, I have them.
Okay. Jean-Pierre, would you like to present Aura? So the thing is, Aura members, Jean-Pierre and Etienne, will present the association. I will then present the work we have done together, and we'll conclude with them too.
I prefer, Boris, that it's Etienne. My English is so poor. I'd be afraid of the result.
So please, Etienne, join us.
Okay. Can you hear me?
Yes.
Okay. Yes. Okay. Next slide, please. So I have the pleasure to present Aura to you. So I'm not going to make a technical presentation. It's a general presentation of our non-profit organization. Okay. First, some word about the disease itself. What is epilepsy? Some people know about epilepsy. A lot of people have epilepsy people in their family, so may know a little bit about epilepsy. First, epilepsy is known with seizures. So seizures lot in epilepsy are not predictable, very hard to predict, and there are a lot of different types of seizures. And seizures are known with convulsions. The patient may fall, may hurt, may be hurt, may be wounded, and they have strange sensations, strange emotions, sometimes strange behaviors. They move very quickly. And so there are a lot of different types of epilepsy, but the most difficult, the most important consequence of epilepsy is the direct consequences, because those people find hard to live, to work, to have a normal daily life, because anytime they may have seizure. Okay, so they are suffering of anxiety, stress, as well in their private life, at home or at work. They may have accidents anytime. They may suffer for social isolation because they fear being with others. Okay, because epilepsy is not well accepted by the social environment. Okay. In Europe, there are around 6 million of epileptic people, around 50 million in the world, 600,000 in France. So that's a lot of people, and 1/3 of the people with epilepsy are drug resistant. Okay, so they are still suffering epilepsy. They may have some operations, but brain operations, but it does not work all the time. So 1/3 of the people with epilepsy still are suffering of epilepsy seizure. Okay, next slide, please. Okay, so we have a mission. We design a mission for Aura, and this mission is to design and industrialize a device This device, you can see you have the epileptic person on the left side, and the disability person has a patch. Okay, the patch is on the body and the breast of the patient, and this patch record all signals from the heart and also all movements. Okay, and with these signals, we of course then we are going to analyze the signal, and all the recording signals are sent to the smartphone, and this allows us to give information to the patient about about his epilepsy and about the will give him a lot of information about his epilepsy. Okay, so our objective is to analyze in real time in the patch with calculation algorithm, analyze the signals, movement and heart signals, the electrocardiogram, and to detect early signs of seizure and alert the patient. Next slide, please. Okay, so in order to develop those algorithms, we have been working on a machine learning factory. All signals are recorded in a timestamp database. So that's a big one. And so we have a pipeline with machine learning. It's quite a complex one, which is now running in a secure cloud in our hospital partner, La Tep, south of France. So our team of data scientists can work on it, as well as the neurologists who are doing the annotation. And then, of course, you can see that we work with the ML factory. About that, we will reload the algorithm in the patch, which is on the patient body. Okay, next slide. Okay, that's where we are today. We have developed already a couple of algorithms. That's very important to say that we're working in open science. It means that all our work are open to anybody. We use, of course, already code and data from the open world. We use today open data from TUH University, which is an open data with algorithm, as well as an open data from Grenoble. And all our code also is in open source. It's published on the GitHub, and all our results and algorithms are published as well as open code and open algorithm. So it's very important for us for some ethical reason, but also because we are in medical research and development, and we believe that in this field, which is not easy, people have been working for years and trying to find some relevant algorithm for epilepsy. We need to work together. And today, so we're working with the University of Sydney as well, which has done some significant work in epilepsy detection. And so now 2022 is very important phase for us, because we will start in this summer a pilot study, which is going to be a proof of concept for. That's our presentation. Any question? And then I give the stage to Boris. Any question from anybody? Okay, Boris.
Okay. So I'm not going to present Aura again. As said before, they're doing open science, so all of their workflows and everything that we've done with them is open and public. It's on GitHub. We started from a state where the Aura data scientists had developed a prototype already. So they have a AI workflow with a data cleaning step, which is, of course, the most time-consuming step in the process. And then we have the training of the model, which is a random forest model. They run it on they did run it on their machines, and they wanted to scale it up, so make it available on other machines and being able to analyze more data with bigger data sets and so on. Just to say that this was a great challenge with passionate people, a good cause, and with real data science problems. So we really have a few people, scientists working in the lab, and then we want to make sure that other people can run the workflow out of the lab. We want to be able to scale down the time of the full execution. And so that was really an interesting use case. Next slide, please. So the workflow they did set up, we start from two types of files, the EDF files, which contain the ECG signal, so ECG for electrocardiogram, basically the heart beats. And we also have a set of annotations with physiologists saying this is an epileptic seizure and or this is just noise. And with that, we know that with this kind of heartbeat, we have or not an epileptic seizure, and that's how we train our model. But of course, we need to clean the data. So we have a first step of error intervals detection, so which is the time between two heartbeats. So this is Python scripts, all in the GitHub repository. Once again, we also extract the annotations from the annotation files. We compute the features from these two files. We create a smaller data set just targeted for the model training, and then we train the model. Our goals here are to make sure that we can run this workflow, this full workflow, anywhere, because it's a bunch of Python scripts with a lot of requirements, libraries, and so on. So we just want to make to people outside of the lab to run the workflow without to install, spend hours installing all the requirements and so on. Doing so, our aim is to improve the performance of the data sets, of the workflow on the data sets. Because when they developed the prototype, the thing is they're running it on small sub data sets. And at some point you need to run the prototype on the full data set. The full data set is 60 gigabytes. It's thousands of files and so on. So it's not something that you can run in a few minutes. At the beginning of our work, the full execution time was 20 hours on the lab's machines. And last thing, when we work on portability performance, one thing that we want to do is to set up a good structure, a clean structure for the repository, so after our job is finished, people can still use it and still benefit from the improvements we've made. Next slide, please. So the first thing when we want to make that workflow portable is to build containers. So we defined different steps in the workflow and making sure that these steps can be executed one after the other, or maybe in parallel. The two major steps that we have, of course, is the data process step and then the machine learning training step. What we did is that we wrote a bunch of scripts to actually take the scripts, the Python scripts from the repository, put them in the right directory. We wrote some Docker files. And so you just run the container creation scripts and everything is built automatically. That's really important because during our work and after our work, data scientists do not necessarily know Docker and this stuff. So we want to make it easy for them to just develop their Python scripts and then execute the container creation script. So the containers are automatically created. They can push it to Docker Hub and they can reuse it elsewhere really easily. And one important thing when doing so, we relied on the Eclipse Graphene AI for you experiments. Excuse me. So Eclipse Graphene has written a set of specifications for Docker containers to run AI workflows. And the good thing with that is that we can use these containers, if we follow the specifications, we can run these containers within Eclipse Graphene, of course, but it's really easy also to run them with a simple Docker setup or a Docker Compose setup, which you can find almost everywhere. So doing so, we create the containers, and then anybody with Eclipse Graphene, so Eclipse Graphene can send the workflow to a Kubernetes cluster. We can execute them with Docker Compose, and of course, still the Python scripts are still in the repository. So if you want, you can still execute the Python scripts directly. Next slide, please. Then regarding performances, we did two things to increase the performance, to improve the performance of the workflow. First thing, we try to identify the steps that can be executed in parallel. In this case, the data processing, cleaning, preparation step can be executed in parallel. We just have to make sure to define not overlapping subsets. We can run as many containers for the data preparation step as we want in parallel. Once everything is ready, all the data that we had in the dataset has been prepared properly, then we can feed it to the machine learning training step. The machine learning training step cannot be executed in parallel, but we already got a huge increase in performance during the first step, because 80% of the execution time is actually spent on was actually spent on the data preparation step, and the model training is just 20%, something like that, of the full execution time. So that was already a big increase in performance. And the second thing, once we can execute these containers anywhere, we just put them on a more powerful machine. And so in our case, it's one of the servers provided by SDIA, and it's a 48 threads machine, so a lot of CPU power, SSD disks, which was really important regarding the I/O performance, and enough memory to run the data sets. And actually, we were able to cut down the full execution time from 20 hours on their machine in the lab to 4 hours on the AICE server. So that's quite important. Next slide, please. And so to kind of summarize what we've done. So better portability, better performance, and also making sure that the repository and everything that we have set up can be reused in the future. So the next developments can rely on the same repository structure and benefit from the same scripts, set of scripts, and so on, and make sure that for the next workflows they will develop, they can simply reuse our structure and develop new workflows and so on easily. So they can really focus on what they're good at, which is developing AI workflows, and not take care of the infrastructure thing. So we defined the new structure for the repository. We wrote a set of best practices, so making sure that the scripts have their tests, that we can execute them automatically. We did set up a Jenkins instance to make sure that every commit, at every commit, the tests are running fine and so on. Which is the best way to make sure that in the future they will still be able to run everything and benefit from our structure. Now, back please. And one thing about the diminution, the dramatic decrease of the execution time is that when you have an execution cycle that is 4 hours instead of 20 hours, well, you can just run more tests and you can fine-tune your parameters, which is really important in AI. And that's just an opportunity to better optimize the workflow, which you won't do if every execution takes 20 hours. So that's really a game changer for the development of the AI workflows. Next slide, please. And I'm handing over to Etienne, if you'd like.
Okay, thanks, Boris. So this was a fantastic job done. Okay, you have seen the improvement in performance from 20 to 4 hours, which is, of course, much more comfortable for our team of data scientists, as you can imagine, instead of waiting the next day. That's really fantastic. And thanks to Eclipse, now we have a robust code. It was very challenging because I think that our team is already a very skilled team, and with Eclipse, this was even better, and so very important for us to have a very robust code. And now also our code is running in container, and of course we are thinking of the next steps next year, because if we are working with hospitals, clinics, and so on, we are thinking of running in an edge architecture, and so the fact of running in container was very important to us. And of course, it's open data, it's open source, and we had also some discussion with Eclipse about the type of license, because our aim is for next year to find some commercial companies to distribute, support, and sell our development software and patch and so on. And so the type of license we use is very important. So Eclipse has been very helpful for us in this perspective. Okay, and of course, for the next step, we are working on open data, which is not an easy subject. Of course, we will take profit. We will use all the experience with open source with Eclipse. Well, we are thinking about federated learning, as you can see. As I told you, we are working with the University of Sydney, and we may work with other organization. And so federated learning is maybe an important and difficult, I think, a different theme. Difficult work. We need to improve the continuous integration in our factory as well, and as well as the working on high performance computing for the next step, of course. As I show you, we have very important phase here, which is going to prove that our concept is all right, is good. And the next step for the step for next year is going much closer to the commercial and industrialization phase. Thank you, Boris, for me to give you some time to explain about our. Thank you, Gael.
Thank you. Yeah, last slide. That was a very fine and productive example of collaboration to improve maturity of AI development. We bring the expertise our expertise with industrialization and with some infra-related knowledge and so on, and the people from Aura brought in their data science expertise, and that's really how it works well. We wrote a complete report of what we've done, and it's publicly available. You have the link here. Please have a look, and if you're interested, you have questions or whatever, please don't hesitate to contact me. Thank you.
Thanks, Boris.
Thank you.
Thanks, Etienne. And well, just to conclude, so coming next. So next week, if you have the opportunity to be in Cannes, we will have a presentation of the working group at the World Artificial Intelligence Cannes Festival. So that's in
Palace, Festival Palace. Yes.
I'm not sure we'll have the red carpet to go up the stairs, but I hope so. So that's on April 15, and that will also be online. Also, heads up that we are planning a face-to-face meeting at EclipseCon. EclipseCon is our yearly conference. This year it's on the week of October 24. And every year we have what we call a community day, and the community day is the moment when the different working groups self-organize meetups and meetings, and also that's the opportunity to do cross-pollination between different working groups. So typically we would do something with this one that is also hopefully in collaboration with the EDGE working group, I think. So, well, save the date to be with us in Ludwigsburg. That's very close to Stuttgart on October 24. And yeah, we will continue with the monthly meetings. So the next one in May will be with CEA. So we will have a presentation of N2D2, which is a project that will join the AICE working group very soon. We need to confirm the date because we were thinking about a date, but the presenter is not available on that day. So we will publish the date on the mailing list very soon. So that's yet another good reason to join the mailing list as soon as possible. And with that, I think that we have
yes, that's the end. Thank you again
for comments and questions. So yeah, maybe you stop sharing, I stop recording, and yeah, let's get your feedback on this presentation.
Just some words, it's Jean-Pierre. It's very we are very happy to work with Eclipse Foundation, and we will use all these works for us because we have different teams. Imagine that we have 90% of time is volunteer time in RORA. So it's very strongly important to reuse what we do. And now we work on movement, gyroscopic movement, as Etienne says, and all these works will reuse for the data of movement when we finish the first step. Remember also that the most difficult in this work is data, because there are legal problems, there are closely data, and a lot of data are not annotated. And what Etienne says, he says that we work with Sydney University. They develop an imaging system to annotate automatically data. So we also reuse that and we work with them because it's the most time, the most spent time for this part. Imagine that it's 2 years of working to have the first annotated data with our neurologist. So all we do, we hope that all we do with you can be reused with other universities, with other people, and everybody is welcome because it's our strategy. And we also participate in June at the Epilepsy Foundation Forum. We are invited to present our works, and we present also our collaboration with you. So great job together. And sorry for my English.
No problem. Yeah. Well, just to jump on what you just said, that from the Eclipse Foundation side, we are also very happy. I think that we met almost by accident in another forum, and when I saw the presentation, of Aura, I immediately thought, okay, well, that sounds interesting. That would be a very interesting use case for what we do in the context of AICE. So I'm happy that it was that we managed in well, I would say just a few months to put things together and to have this this demonstrator and this what I call a test bed ready. And yeah, that's wonderful. We hope to do more together, but also one call for action is again that we want also more test beds, more use case like Aura. So we have a strong goal in 2022 to onboard at least another use case. So, well, just do not hesitate to reach out to Florent or me or Boris if you have an idea of something that could be such a use case. You see, with this presentation today, I think that you all have the idea about what we have done. And I was mentioning at the beginning, you know, research project dissemination. I think that sometimes in research projects there is some kind of a prototype that is created as a demonstrator, and we can do something similar to what we have done with Aura to how do you call it, to move such demonstrator to the next stage in terms of maturity. You know, I like to say that there is the different levels of maturity. It's not necessarily the TRL, the technology readiness level as designed by NASA, but there is okay, it works on the laptop or in the environment of the developer, and here we bring it to the next level because we managed to make it work in different environments and to make it much easier to onboard for other developers outside of the initial team. And I think that's also one of the beauties of open source.